Hi guys, you're welcome back to Halogenius Ideas. In this video, we are going to be exploring Python lists comprehensively, covering various concepts and methods. Alright, so the first thing we want to cover is how to create a Python list. If you want to create a list, you use the if you want to create a list, this symbol over here, this is the symbol to create a list. So basically, all you have to do is just to assign it to a variable. For example, numbers equal to, then what you have here will be an empty list. All right, so if you come here to print numbers, for example, and you run your program, you see it is giving me an empty list over here. What if I add some elements to the list? One, two, three, four, and five. So, and that is it. So a list is an ordered collection of different elements. Okay, so an ordered collection of different elements. The elements can as well be of different data types. For example, I can have, instead of one, I can have hello over here, hello, and over here I can have true. Okay, so you can see that inside the same list, I'm having a string, I'm having an integer, I can even have a float here, then I have a boolean as well inside the same list, and if I run it, my list isn't shouting. Okay, my program isn't shouting. So that is how to create a list. So how do you now access the elements inside the list? How can you access the elements inside a list? So indexing starts from zero in the programming in Python. Your indexing starts from zero. So if you want to access this first element over here, the index is going to be zero. For this first one, the index is going to be one, two, three, and four. All right. So you can come here to do something like you can come here, and if you want to index just like we did in the strings, you can just say zero and run the program. You see it is giving me hello, which is numbers indexing zero. All right, so if I come here and I write one, for example, and I run this, you see it is giving me two. It is giving me two. If I say four, for example, and I run this, it will be giving me five and zero, one, two, three, four. Okay, four is basically the last element in the list. So if you remember vividly, we did positive indexing and negative indexing. So let me clear my terminal. If you want to index from the other side, so this last element over here will be negative one. So that will be negative one. If I run this, you see I'm having five, which is the last element. So you can index both positively and negatively. So if I do something like negative two and I run this, it's giving me true, which is the second to the last element in the list. Okay. What if I do something like negative 10? Guess what? It will be giving me index out of range. Okay, because there's no tenth to the last element in this particular list. And if I should come here and say positive 10 as well, if I run this, you see it is also giving me list index out of range, because there is no tenth element in the list. The last element, the index of the last element is going to be the length of the list, which is the number of elements in the list minus one, because indexing starts from zero and not one. So obviously, for this five over here, the index is going to be four. Okay. So just like we did string slicing, you can also do list slicing, which is basically you getting a sublist of a list. Okay, we have the whole. You want to get a portion of the whole. That is what we call slicing. So what if I have something like, let me create only numbers. Let me create a list of only numbers. So one, two, three, four, five, six. Okay, I don't like the fact that they are numbers that follow each other. 10 to 31, maybe 73, 82, 54, then maybe 61. Okay, so I have all these elements in the list now. If I want to index from the beginning up to 73, if you remember what we did in string slicing, you will notice that we have to stop at 82 if we want to include 73, simply because the um, the stopping point is exclusive. So normally I can start from index 0, then I will index up to 0, 1, 2, 3, up to index 3. If I should run this, you will see it is giving me 10, 2, and 31. It is not giving me 73. Like I said, the ending point is exclusive. So if I want 73, I have to make it 82. I have to stop at 82. So you can see it is not giving me 73. So that is how to do list slicing from the beginning. And since I'm starting from 0, I can just remove this and I'll run my list like that, and it will still give me the same result. What if I want to start from 2? Okay, from 2 to 73. So I'll just come here and start from 1 and I run this. So that is from 2 to 73. All right. But what if I want to index from 73 till the end? Okay, all I have to do is just to do something like 0, 1, 2, 3, and that is it. If I run this, you see it is giving me 73, 82, 54, and 61, which is basically 73 till the end. All right, 73 till the end. So that is how you can do list slicing. You can also use negative indexing to slice your list. For example, I want to slice maybe 31 up to 54. So definitely I'm going to be doing -1, -2, -3, -4, then -5. So I'm starting from -5 and I'm going to be stopping. I want to stop at 54. So that will be -1. But if I, yeah, that would be -1 basically. So if I run this, you see 31, 72, 82, and 54. It will not include -1 because the ending point is exclusive, like I said. So how do you modify a list? Okay, you can modify the elements in a list. But how can you do that? Very simple. The first thing you want to do is to index the element that you want to modify, then you assign the new value to it, and that is it. So let me clear my terminal. So come here and do something like this. Numbers, I want to change 73. So that will be 0, 1, 2, 3. Numbers indexing 3 equal to maybe 45. If I should run this, take note. For my original list, I have 10 to 31 73, but now I have 10 to 31 45. Okay, you see that I now have 45. That is basically how you can modify the elements you have in a list. And guess what? You can even change this one to another data type entirely. For example, Alexander. If I run this, you see what I'm getting over here. So that is how you can modify the elements in a list. All you have to do is to index that element, then you assign the new value to it. So that is how you can, like I said, modify the elements you have in a list. Now let's talk about a few list methods. Let's talk about a few list methods. So let me take this one out. So let's talk about a few list methods. The first one we're going to be talking about is the append method. The append method. So how can you use the append method? All you have to do is to, for example, I have 10, 2, 1, 73, and all these other elements in the list. What if I want to add another element? I want to append another element. I can just say numbers, then dot append. Okay, numbers dot append, then I'll append my maybe 7. Okay, if I should come here, print my numbers, you see that I now have an extra number. So initially this list stops at 61, but now I have 7. All right, so that is append for you. You can also remove an element by, instead of append, you can say, okay, let me leave the append. So numbers dot remove, and what element do I want to remove? 10. And you can see that 10 is in the first index over here. So if I should run this, you see that 10 is gone now. Okay, you can see that 10 is gone. So initially my list starts from 10, but you can see the one that I brought to the terminal, it is starting from 2. So that is how you can remove an element from a list. So another thing that we can talk about is list concatenation. List concatenation basically is you bringing two lists and you joining them together. You have two lists, you join them together. That is list concatenation. All right. So how can you do that? Let me take all these ones out. So I can come here and say even equal to 2468, then odd equal to 1357. So then you can say full, or let me say all equal to even plus odd. So print all, no, so print all. If I should run this, you see that now I have 2468, then 1357. Okay, so that is how to combine concatenate two lists together. That is how to concatenate two lists together. You can also check the length of a list. The length of a list basically is the number of elements that we have in the list. Okay, the number of elements that we have in the list. That is what we refer to as the length of a list. How can you do that? All you have to do is just bring in the len function. The len function. For example, this is how it works. Len, then you pass in a list. Don't forget that all that we have over here is a list. Don't forget that all that we have here is a list. And we have eight elements here. So if I should print this, you can see I have eight. Okay. So that is how to find the length of a list. If you want to find the length of odd, length of odd. Okay. We can use the len function to check if a list is empty or not. How can you do it? So you can just say maybe arr. Let me take all these ones out so I have enough room for new stuff. So I can do something like arr equal to a list which can be empty or not. Then I'll say if the length, or I don't have to put this, if the length of arr is equal to 0. Okay, then I'll just say print the list is empty, or else you can say print, let me use a formatted string here. If no, the list has a total of, then I'll bring this in. So length of array elements. Okay, no, so if I should run my program now, you see that the list is empty. The reason is because I don't have any elements inside this list. But let me just come here to steal some of the elements I have over here, and I put it inside. Guess what? If I should run this, it is giving me the list has a total of 7 elements. Okay, and the reason is because, like as we can see, I have 7 elements over here. So that is one of the ways we can use the len function. You can also check if an element exists. Okay, the membership operator, if you remember. So to check if an element is present in a list, for example, so um, let me take this one out. I can say print 2 in arr. If I should run this, it will give me true, and the reason is because you can see that 2 is actually a member of the arr list. Okay, what if I say 22 and I run it? You see, it will be giving me false because 22 doesn't exist in arr list. What if I say 82? You can see I have 82 over here. So run it, you see I have true. So that is how you can check if a particular element exists in a list. So the last thing that we are going to be doing is the nested list. All right, the nested list. So a list can contain other lists, creating the nested structure. All right, and this is predominant in matrices. Or you might be having a list of list actually. That is the a more simpler way to explain the nested list. So you can be having something like this. You can be having maybe a matrix, and say this matrix, you're going to be having a list over here. So 3, 7, 24, then you have a comma. So you're going to be having maybe 4, 2, maybe 8. Then you have 1, maybe 13, then maybe 6. So this is an example of a nested list, all right? This is an example of a nested list to make it look nice. So you can see that I have, for every other list that I've been working with, I have an element which can be a number, a float, a primitive data type basically. But for this other one, I have a list inside an original list. This is the outer list and this is the inner list. Okay, so how can I index these elements that are inside of the inner list? So let's take this matrix for example. This is the first row, this is the second row, and this is the third row, and everything can be on the same line. Okay, everything can be on the same line, so we don't get confused. Everything can be on the same line, so I can put everything on the same line like this. It is still the same thing, all right, but just for it to um, have a better presentation. So now I can print matrix, and this matrix I'm going to index maybe 2. So this will be the last row obviously. If I run this, 1, 13 and 16 is what it's giving me. So clear. So like I said, if I run this, I have 1, 13 and 16. What if I want to index 13 for example? So that will be 2, then 1. If I should run this, it will be giving me only 13 because this first index is going to be indexing this one over here. Now the second index is going to be indexing the first element inside of the second index of matrix. Alright, if I want to index 24 for example, this is going to be 0 because it's in the first element. Then for the 24 I can use negative 1. Okay, run this, you see it's giving me 24, and I can do 0, 1, 2. I can use 2 instead. The reason I can use 2 is because 24 is the last element inside the list. Okay, 24 is the last element inside the first element, which happen to be a list of um that is the elements in matrix. All right, so that is how to index your elements if they are in the nested structure in the Python list. So Python lists are dynamic, they are versatile, and they are widely used for various programming tasks. Understanding these concepts and methods will empower you to manipulate and leverage lists effectively in your Python code. So that will be all for lists. Watch out for the next tutorial where I'm going to be talking about tuples. By the time you're watching the tutorial should be out. So yeah, thank you very much. Don't forget to like the video. Don't forget to subscribe to the channel. If you have any questions, please, the comment section is open. You can always drop it there, and I'll respond as soon as I can. Thank you very much. I'll see you in the next tutorial. Bye for now.